Hi, everyone. This week we're continuing our study of mechanical equipment for heating and cooling of buildings. First, we'll talk about some overall design guidelines for mechanical systems, rules of thumb for their size and location, and then some specific guidelines for energy efficiency. Then we'll focus in closer on the individual components of your air supply system, supply and return air, ductwork, grills, registers, etc. And finally, we'll talk about ventilation. Um, what is indoor air quality? Why do we care? Why do we ventilate? Some code requirements for ventilation and a look at the different systems that can be used. In the beginning of architectural design, right in the initial stages of the projects, you're not going to know which type of mechanical system will ultimately be the correct one for your building, and you won't know the specifics of that system. It depends on many variables, such as the specific building size, location, and use. Um, what space you have available, the particular building aesthetics, all right? But even more than those, it depends on efficiency, uh, it depends on building codes, and absolutely the bottom line, it depends on cost, initial cost and life cycle cost. So since the mechanical system is such a large part of the building, at the schematic design stage, way in the initial phases of the project, an architect should plan ahead to incorporate this system. Let's talk about size first. In general, and this is just a rule of thumb, all right, the mechanical system will take somewhere in the 6 to 9% range of the total floor area of the building. And your textbook gives you a little chart here of some of the sizes of this equipment. All right, and it's given in percent of the total floor area. Now let's talk location. For your medium-sized buildings, you would typically place your equipment on the roof or a mechanical equipment room. Right? If you choose the equipment room, you want it to be centrally located, somewhere in the middle of your building, to minimize your duct runs, and then you can make them smaller. You also want to provide access from the outside so that you can service this equipment and also move it in and out. For your larger buildings, especially your multi-story buildings, you're going to place your mechanical equipment either in the basement, on the roof, or sometimes there's an intermediate floor that turns into a mechanical room floor, basically. Your cooling tower then will typically be placed on the roof, or if you have somewhere on the site adjacent, it can be at ground level. Sometimes a mechanical equipment room is needed on each floor or maybe every couple of floors. And if you do that, you want to kind of follow the similar rules to those medium-sized buildings. Put them kind of in the center of the building again, so you reduce your duct run lengths and thus reduce your duct sizes. And also provide outside access. That's not necessarily so that you can bring equipment in and out because that would require a crane or a helicopter or something, but just to provide outside air. Finally, let's talk about design guidelines for energy efficiency specifically. Your textbook gives this whole list, all right, but you can kind of subcategorize those. Let's take a look at it. The very first thing, the highest priority, the lowest tier in designing mechanical systems for energy efficiency is to reduce the heating and cooling load. You design the building itself so that it needs less heating and cooling. orientation, form, passive heating and cooling systems, shading, thermal envelope design, etc. Right. Next, there's a lot of things you can do to consider the most efficient distribution of heat from your heating and cooling equipment. Remember that it can be distributed by air, water, or electricity. All right, so consider some different ways to do that. Next, you want to plan efficient ductwork and ventilation systems. Use large diameter, short length, straight run ducts. You'll get much better efficiency. All right. You want to place your ductwork on the inside of your thermal envelope and not outside. Again, very important. And some other options. So we've just discussed design guidelines for mechanical systems kind of in general. Now we're going to focus closer in and talk about those individual components of your air supply. Thank you, everyone.